All right, so one of my longtime clients has been having issues with their fork trucks or their forklifts, whatever you want to call them. This is a guard that goes basically where the forks go, and it's supposed to protect a few hydraulic lines. But as you can see, it's pretty light duty, and they've been poking holes in them. They get all bent up. The expanded metal, this mesh stuff, starts breaking off. This one's not even that bad. This is the best one they could find me to make a new model off of. The rest of them are all destroyed or just not even on the machine anymore because it broke so much that these started interfering with the hydraulic lines. So I made an updated version. I already installed it on one of their forklifts, and they approved the design, and now they've put an order in for 6 more units. So I'm going to be making these along with some mounting brackets for it and then installing them on their fork trucks. So this is basically the design I came up with. I've done a bunch of math here, calculating how much steel I needed to make the first unit as well as the other 6. But basically I'm making the same size frame because it has to fit in the same spot, but we're going to have 1/2-inch square stock going in an X pattern with a vertical in the middle to offer extra support, and also the entire outside frame is going to be made of double the thickness of what the original was. So this is how I design my stuff. I just use a grid paper pad. You can use a computer and everything, but I find it easier to just use pen and paper for small projects like this. If I was doing something more complicated, I would definitely use some sort of 3D modeling program eventually. Anytime you're building multiples of the same item, you gotta cut all your materials. And it's all being cut to the same measurement for every single unit, so I'll just cut all of the pieces all at the same time at once. So I have 4 pieces of flat bar up here right now, and I'll cut all 4 at the same time and just clamp them together. Okay, so there's all the borders cut for the frame. Just got to assemble one of them and then take the measurements for the reinforcements. So in this clip here, I'm just beveling the ends of the flat bar wherever they intersect with each other. I'm just doing this to get more penetration because it's all butt welds. And if you just do regular butt welds, they're pretty weak. So anytime you can put a little bevel in there, it helps. But you're going to see a theme in this entire video of where I'm just kind of using basically home hobbyist welding tools. I don't really use any expensive equipment in this video. I don't use any sponsored equipment in this video. I just use some of the tools I've already had and have already paid for themselves. And I guess what I'm trying to show here is that you really don't need thousands and thousands of dollars of tools to get out there and get some work and make thousands of dollars. You can have just the basic stuff and get by depending on what you're doing. And in the end, after I designed these guards, built them and installed them, I charged thousands of dollars for about 8 of these things. And it was really good profit margins. But that was because I didn't go buy any extra tools for this job. I used what I had, and I streamlined everything by thinking of efficiency and thinking the best way to do it with what I had. And that ended up speeding things up a lot. As you're going to see, I do a few tricks later in the video. One thing I see that it seems to be a big misconception on especially Instagram when it comes to like running your own welding business is everybody sees the equipment that everyone runs. Guys like to show off their tooling. They like to show off, big heavy duty trucks, big, diesel welding machines, fancy flat decks or service trucks with cranes. Or if it's a shop, they like to show off their really fancy shop gear. And I think the mindset to have when purchasing tooling for your business is you go into it purchasing something because it's costing you money not to have it. Not because it could potentially make you money in the future. It needs to be making you money the second it arrives at your door. That's kind of how it should be. If you just go out and start buying stuff because you want it, not necessarily because you need it, I mean, you're going to be spending all your profits away. And yes, I know people think, oh, with the taxes and everything, you need to spend all this money on tools because it gets just refunded. That's not how write-offs work. Yes, you get a break on your taxes, and sometimes your accountant may tell you to go make a big purchase or something. But unless your accountant is telling you that, don't tell yourself you need to do that. That's your accountant's job. They know what they're doing. You don't. So don't go and purchase stuff thinking it's better for your business, even though you don't need it. Because, man, if you just want to run a business to get the cool tools and show off all the equipment you have, that's kind of depressing. I'd rather take that money I would spend on really fancy tools and put it into something like a vacation home eventually, or going on vacation, or doing something for fun outside of work. If you just base your entire life around your business and that's your identity, that's kind of depressing in my opinion. So make sure that when you're buying stuff, you're buying it because it's costing you money not to have it. Now here's a big time-saving trick that I did. Instead of taking a measuring tape and laying out all the rectangles of expanded metal I needed, all I did was go over to the frames already built, which were already the exact size they were going to be. I did all the measurements for that. I just took that and traced it onto the expanded metal for every single piece I needed. That way I'm not doing any measurements, I'm not doing any math in my head. I'm just purely going over there and basically tracing it and using it as a copy-paste tool to get the exact size of each piece of expanded metal I needed. This saves a lot of time, it saves using your brain, and kind of any time you can use some sort of jig or anything like that, or trace something, do it, because it's way easier and it saves a lot of time. So as you guys have been seeing, I tacked everything together with this Lincoln MiG 140. I'm using flux core wire, and I have it on its max power output. That's good for tacking all of this together, but for actually welding it out, I'm not going to use this machine. I'm going to use my Yes Welder TIG machine, and I'm going to stick weld it all with 7018. The reason I fully assemble them and tack it all together first before welding is because when you weld, everything likes to start warping. So if you have it fully assembled and then start welding, it'll warp less. So yeah, this thing, it just doesn't have enough power really to do these single pass welds, in my opinion, on this thickness of material. Obviously a stick machine will. Preferably, I'd rather use a larger MIG welder that has more output, and I would use a dual shield flux core wire or a hard wire MIG weld wire instead of just gasless flux core. So in this clip here, on one side of each guard, the side that gets the expanded metal on it, I had to grind the welds flush. So that just shows more why I beveled the ends of the flat bar as well. Because one side of the weld was completely getting ground off. So beveling it just helped make a little bit of a stronger weld, especially if you're going to grind one side off. So in this clip here, I'm just using one of the pieces that's already cut to length to measure the length of the next piece. I do this all the time. You just put it flush up against the blade, and it saves you from pulling your measuring tape out and taking another measurement. So basically I laid out, I don't want to lay out the holes on every single guard. I don't want to have to take it, measure them, mark them with the Sharpie, center punch, drill. I just want to be able to take this guard and put it on top of another guard and then drill through these spots with the same size drill bit. That way I'm not doing any measurements, I'm just mirroring the holes, and it saves a lot of time. And I'm going to do the same thing with all these mounting angles since I've got one on here. That's how I do it. It's not as accurate as measuring and laying them out every single time because the dimensions on every guard aren't going to be perfect. But these holes are a little bit bigger than the actual M8 hardware that's going to be used to mount it. So there's a room for a little bit of error, but that's how I do it in this scenario. It's going to work and it's going to save me tons of time. So you can see here, I got some of the angle iron clamped together, one with the holes already in it, and I just put the drill bit in and do a quick spin in each hole, and then the center of the drill bit marks the center of the hole on the other angle iron. And as you can see there, they're face to face, those pieces of angle iron. So why it still works in that scenario, I mean, ideally, like the guards, I could put one on top of each other and transfer the holes, but the angle iron, you can't put them like that because there's a leg on the bottom side. So if your holes are symmetrical, you can put them face to face and it still works. And yeah, basically the same theme coming back again, just using the first original piece as a template for all the next ones. That way it saves, lots of time from measuring everything out, marking it, and then drilling. So in this clip here, I just have some C-channel on the bandsaw, and I'm slicing them up, and then I gotta cut them in half again with a grinder. And basically these are just some more mounting brackets for these guards. I didn't really film too much of this process. I had to do tap some holes in these as well, but I didn't film it, so that's what they are. The day, the biggest thing I can tell someone for doing work like this, where you're fabricating in your home shop or whatever, definitely keep track of your time, because if you're not, you can get away from you so quickly and you will have no idea how long it took you to do something, or you'll have a general idea. But if you aren't tracking it and you have no clue, you're just going to be taking shots in the dark every time you're going and quoting something. So you really need, I highly recommend keeping track, and that way it just helps you later on, because organization on this kind of stuff, in my opinion, is key. If you're not organized, you're probably gonna lose some money somewhere. So again, here's a photo of the original one where it had a hole poking through it and they were messing up the hydraulic lines. Then you got the new ones at the facility. I'm bolting them up on the machine. They look pretty good. I was able to work with the operators at this warehouse and set it up pretty well, where the second I was done one, they would come grab it and then they would drop another forklift off for another guard, because this place is running all the time. So it worked out pretty well in the end. Ended up making really good money on this, again, because I figured out how to make things go faster. If I would have just took my time and did really conventional methods of fabrication, where you measure everything and this and that, it would have definitely hurt my hourly income on this one. But because I used the tracing methods and mirroring and everything for holes without having to take measurements, it has saved so much time. So in the end, I came out pretty far ahead on these. And again, you saw I didn't have any fancy tooling really at all, and it all worked out pretty good. So yeah, don't be afraid to take on fab projects with basic tools, as long as you have the knowledge on how to make it work with what you got. You can see the one mistake I made here. One of the mounting brackets, I guess I measured the holes wrong. I took time to drill them and put slotted holes in the brackets and everything, and in the end they didn't even line up with where they needed to be. But luckily I had my drill and everything there, so it only took an extra minute on each, 2 minutes on each install to just drill a new hole through that mounting bracket. Again, using the guard that's already there as the template, and just drill a quick hole through, put the bolt in, bolt it up, and it was all good. So that didn't really cost me much time, but I took a picture in case next time I have to build some more, I know the exact measurement.